4, 6, and 4, 7. 4, 6. We're going to use congruent triangles to prove that corresponding parts are congruent. So when we use one of our shortcuts to prove that triangles are congruent, we only have 3 out of 6 parts congruent. What about the other 3 parts? Well, once we know a whole triangle is congruent to another triangle, we know that all 6 parts of a triangle are automatically congruent to all 6 parts of the other triangle. We call this CP-CT-C. So you're going to use, and if you use this reason in a proof, you're going to abbreviate it. CP-CT-C. So learn that. It stands for corresponding parts of congruent triangles are congruent. So even the unmarked parts in the triangles that are congruent are going to be, the corresponding parts are going to be congruent. That's a good test question. What does CP-CT-C stand for? So put a little star by that in your notes and know that it stands for corresponding parts of congruent triangles are congruent. Let's see how it works. So in this, how can we use the information to explain how the angle letter parts are congruent? So we're given angle 1 is congruent to angle 2. So let's mark that. Angle 1 congruent to angle 2, and RTQ congruent to RTS. Those 2 angles are congruent. We've got to prove that QT is congruent to TS. So, how could we prove that these 2 triangles are congruent? Which shortcut? We can't directly say that QT is congruent to TS. We have to show the triangles are congruent first. And we don't know anything about QT and QS, but what other parts can we use to say the triangles are congruent? Yeah? No. Whenever I have, what do I always, anytime I have 2 triangles that are connected by a line, what do? I mark that line congruent to itself, right? That's what I'm going to do in this case. So we're going to say that RT is congruent to itself. Now, which shortcut can I use to say the triangles are congruent? Well, start at one of the congruent parts. We'll start at this angle down here at Q. Let's go counterclockwise. Q, skip a side. Angle. So I've got 2 angles next to each other, right? Angle, angle. And then I've got the side. So the triangles are congruent by angle, angle, side. That's how I know QRT is congruent to SRT. Then as a result of that, after I've shown the triangles are congruent, then I can say QT is congruent to ST by CP-CT-C. Let's go back. So this is just telling you, if you can show that we did that, we show the triangles are congruent, we will know that QT is congruent to ST. Here's the reasoning. This is just going through what we talked about. Now, one thing about you always use CP-CT-C after you say triangles are congruent. You will never use CP-CT-C until you've shown triangles are congruent. So it won't make sense in a proof when we're doing a statement of reason proof to have CP-CT-C above congruent triangles. You'll see when we do some more examples. All right, here's they're given, says to see the picture. And we have to prove that angle A is congruent to angle C. So what do you think my first two statements are going to be? What usually goes first in a proof? Bobby? Jacob? The given. Right. So we'll put those first. We'll say AB is congruent to AD. No, not AD, sorry. AB is congruent to BC. And that's by given. And we'll say AD is congruent to CD. And that's by given. What else can I mark congruent in these triangles? Yes? Yes, they're connected by a line. We mark that line congruent to itself. So BD is congruent to BD. And that's by, what's the reason for that? What do we call that, Levi? That's by reflexive. Now, do I have enough to say the triangles are congruent? Allie, go ahead. Why?
Side, side, side.
Yes, they're congruent by side, side, side. So I'm going to name them correctly. I'll call the first triangle ABD. Triangle ABD is congruent to triangle. The C goes with the A. They correspond. So it would be CBD. And that's by side, side, side. And then what I have to prove is always going to be my last statement. Angle A is congruent to angle C. That's step 5. How do you think I know that? What would be the reason? Sydney? Yeah, that's your CP, CTC. CP, CTC. Those parts correspond and they're in congruent triangles. Questions? Okay. Okay, because of time, I'm going to skip this example. So let's look at, okay, so we can sort of summarize it since there's so much on it. So we're finding the distance across a river from end to P. We couldn't measure that because we couldn't go across the river. So, but we know that we could measure L to K and show that that's the same as NP. To show that they're the same, it told you that these were right angles, these are vertical angles, and then these two distances would be the same. So we'd show the triangles are congruent, and then we could measure KL and show that NP is the same. They're congruent by angle side angle. Is that in your notes? That example in your notes? No? Okay, so let's don't worry too much about it. Let's do this. This is in your notes, right? All right, so complete the proof. YX is congruent to WX in that drawing. How do we know that? It's given, right. That's given. ZX bisects angle YXW. How would I know that? It's given. Right. And then step 3, angle YXZ is congruent to angle WXZ. Those two angles are congruent. How do I know that? It's not given, so it's got to come from previous steps. How would I know that? That those two angles are congruent? Well, we had in the previous step that the angle was bisected, right? So if the angle is bisected, that means those two angles would be congruent. So that's definition of bisector. And that comes from step 2. Then we've got XZ congruent to itself. What would be my reason for that? Reflexive. That's reflexive property. So how can I say these two triangles are congruent? YXZ and WXZ. How do I know they're congruent? Caleb. Yes. Side, this angle, and that side are congruent to this side, that angle, and that side. So yes, it's a side angle side proof. Then we're going to say YZ is congruent to WZ. Why do you think I'm going to say they are congruent? They weren't originally marked congruent. We didn't show it in our proof, but we have the two congruent triangles. So what do you think that reason is going to be? Trent, what do you think it's going to be? CPCTC. Yeah, that's what CPCTC. Most of the time, if it's parts of triangles, you got to show they're congruent. It's going to end with CPCTC. So, in this proof, you've got the first two are given to you. Then you know the last one's probably going to be CPCTC. So really, you just have 3 steps you have to figure out. A lot of time in the proof. After you've given your given, you just have the remaining steps and the CPCTC. All right, let's do 4-7. We'll try to go through this pretty quickly. 4-7. Use isosceles and equilateral triangles. Our objective is to use theorems about isosceles and equilateral triangles to solve problems. First, we need to know how to refer to the parts of an isosceles triangle. The base is the third side of an isosceles triangle, the non-congruent side. These two are congruent. The base is the third side, the non-congruent side. Unless it's an equilateral triangle, then possibly it's congruent to the congruent sides, and you just designate one as the base. The angles that are on either side of the base are the base angles. The two congruent sides are called legs. And the angle between the two congruent legs is called the vertex. Let me get those tests back from those of you that I passed those back, because I think we're going to be rushed here at the end, and I want to make sure I get it. Anybody else? Did I get it from everybody? All right. Vocabulary. Base angles theorem. If two sides of a triangle are congruent, then the angles opposite them are congruent. So if I have these two sides congruent in a triangle, I know those two angles. You can call it the base angles congruent, or you can just write opposite sides congruent, comma, opposite angles congruent. If the opposite sides are congruent, then the opposite angles are congruent. Converse of the base angle theorem. It says if two angles of a triangle are congruent, then the sides opposite them would be congruent. So it would be marked like this. If I have a triangle marked like that, then by this converse, I can say this side is congruent to that side. They're interchangeable. And then you can just write, if you can't remember which is the converse and which one is not, just write in your reason, put opposite angles congruent, comma, opposite sides congruent. In that order for the second one. And then that'll be fine. Complete the statement. If HG is congruent to HK, we mark those in the figure, then what angles can I say are congruent? I could say angle HGK is congruent to angle HKG. I could say those two angles are congruent because those are the base angles of that isosceles triangle. If KHJ, that angle, if this angle is marked congruent to that angle, then I can say HK is congruent to KJ. Opposite angles congruent, opposite sides, then the opposite sides are congruent. Corollary to the base angle theorem. If a triangle is equilateral, then it's equiangular. If we have an equilateral triangle, we know it's going to be equiangular. And then the corollary to converse of base angle theorem. If a triangle is equiangular, then it is equilateral. Find the measures of P, Q, and R. So the diagram shows that PQR is equilateral. Therefore, by the corollary to the base angles theorem, triangle PQR is equiangular. So angle P would be congruent to angle Q, which is congruent to angle R. So a proof of that, angle 3 is 3 times the measure of angle P equals 180. Since all the angles are congruent, so that'd be the triangle sum theorem. Then we would divide both sides by 3. We get angle P is 60 degrees. So all the angles are going to be 60 degrees. Find ST in the triangle at the right. Okay, so this triangle is equiangular. All the angles are the same. So we know all the sides are going to be the same. So if UT is 5, we know ST is 5. That's my solution. All right, we got through it all. Good.